All right, so I now have open both the Excel spreadsheet and the past window. Your window for past may look a little bit different because the version that is available to you on the website is a newer version. This is version 3, and what you can get off the website is version 4. Version 4 is actually a little bit easier to work with. All I'm going to do now is I'm going to copy these values from our Excel spreadsheet, and I'm going to paste them into the past window. So let's do that. Here I'm going to highlight those numbers and hit Control C. And I'm going to move over here into past and click that cell A1 and simply hit Control V, and now my numbers are pasted into place. What I'm going to do is I'm going to change the name of column A and B. So I'm going to click this little thing up here that says column attributes. And now I'm going to go to the name and I'm going to type in a name. These are the females, so I'm going to type females. And I'm now going to go hit the tab button, go over to the males or to the next column and type in males or male. Very good. So now I have my two columns renamed. I'm going to go back here and unclick the column attributes tab, and I'm going to maximize this window. Very good. Now what I want to do is I want to highlight my numbers, so I'm going to make sure that I have cell A1 clicked. And this version is just a little bit sneaky. Very good. And I'm going to drop down here to the male column, the bottom at 11, and hold down the Shift key while I left click on the mouse. And now I've highlighted my data. Now I'm going to go up here to the menu where it says plot. I'm going to click plot. And I'm going to drop down here to this option where it says bar chart box plot. I don't want the bar chart. I want the box plot. So I'm going to click this anyway. And it now gives me this nice little window. What I'm going to do where it says plot type, I'm going to change that to a box plot. Very good. Let's make this thing bigger so we can see what's going on. And I'm going to do one other thing. I'm going to go over here and click this box where it says Outliers. And now I get these extra little dots in there. So let's talk about what this graph is telling us. On the x-axis here, I have females and males. And these boxes essentially divide the data up into quadrants. So this middle horizontal line inside each box is the median. So half the numbers are below the median, half are above. The other two parts of the box, this lower line here and that upper line, are referred to as the quartiles. So this bottom one is the second quartile, and this top one is the third quartile. The median is the second quartile. Oh, I misspoke myself. This bottom one here is the first quartile. This next one is the second quartile or the median, and the top one is the third quartile. So I now have my data divided up into 4 groups. The bottom 25% of the data, the next 25%, the next 25%, and then the top 25%. And that's true over here as well. Notice that this box over here, though, doesn't have these whiskers. So there's something funky about this distribution of data. Well, that's a consequence of the fact that there were so few males in the sample. Nothing for us to concern ourselves with at this point. The final thing we need to talk about are these little circles here. Those are referred to as mild outliers. If those little circles were black, they would be extreme outliers. An outlier, a mild outlier, has a probability of occurring 7 times out of 10,000 observations if the data follow a bell-shaped curve, that is, if they are normally distributed. Well, we have 3 of them out of about, 12 observations or something, so our data are pretty clearly not bell-shaped. We don't have a normal distribution of the data. We're not going to concern ourselves with that at this point. We'll worry about that later on in the semester, perhaps. Now, if we had extreme outliers, little black circles, the probability of getting one of those black circles, if the data are bell-shaped or normal, is 2 out of 1,000,000 observations. Fortunately, we don't have any of those. But here's what the graph is telling us. You can see by looking at this that, first of all, the female weights tend to be higher than the male weights. And in fact, if you look at this box, from this first quartile up to the top, that's 75% of the weights for the females. And those 75% of the females are bigger than all of the males from here on down. So that 3/4 of the females are bigger, right, than half of the males. You can just get the sense, looking at this graph, the females seem to be bigger than the males. So there's another line of evidence we have for our hypothesis. We've now evaluated this hypothesis that males are bigger in 3 ways. We've looked at the averages, and the averages were not consistent with our idea. We looked at the t-test. The t-test was not consistent with our idea. And then finally, we've constructed the box plots. And it again shows that it's not consistent with our idea. So at this point, it seems we're going to have to reject, we are not supporting our research hypothesis. We're going to reject our alternate hypothesis. The system doesn't work the way we think it does. It works in some different ways. Something else is going on with these animals. They don't respond as humans do. Obviously, something else is happening. Very good. I will see you guys next time.